Hi everybody, welcome to another video in course Algebra, section 3.6, polynomial and rational inequalities. So pretty much what we will have is inequality where f of x is a polynomial function or f of x is a rational function. We do that in the later part of the section. So polynomial inequality is just inequality where the function is a polynomial and on one side the left hand side is 0. So we have one of those four forms. So it's not just equal to, it could be greater than, less than, greater than, equal to, less than or equal to. Those are the four scenarios. And we have polynomial one side, 0 on the other side. Right. Now, the way we solve polynomial inequality, first we have to make sure it is in the right form. Right. And after that, we just go ahead and solve for find the 0, and then we choose a test point and construct the sign chart. So we just jump right into the example. I will go back and explain the idea behind this. But bottom line is, in this case, the f of x, a polynomial function, so it is continuous, and that is an important fact, and that we will see later. Right, x squared plus 5x plus 6. Now if we solve it, first we need to make sure that it is 0 on one side. So we minus 6x on both sides. So that gives us x squared plus 5x minus 6x equal to 0. Sorry, greater than or equal to 0. And so that gives us x squared minus x greater than or equal to 0. Right, so it is in the right form, and in this case f of x is equal to x squared minus x. Right. So we have the right form and the function. First we find the 0 for f of x, or we just go ahead and solve for when f of x equal to 0. When f of x equal to 0, we have x squared minus x equal to 0, and here just simple factoring. So we have x equal to 0 or x minus 1 equal to 0. So x equal to 0 and plus 1 on both sides. We have x equal to 1. Right? So we have x equal to 0 and x equal to 1. Right? So we just going to write that over here, so we will see the whole problem on one screen. Right, so make sure in the right form, polynomial on one side, 0 on the other side, and then solve for the 0 of the polynomial function, 0 and 1. Next we have the test point and the sign chart. Test point or the sign chart. Right. So first I wrote the line, just write the number line, but not quite, just make it more like a table. Right. The top one is, we have the x values on the top, and the bottom will be just this inequality, or just write a function. Right. And next we put the zeros into the number line. So if x equal to 0 and x equal to 1. When x equal to 0, the function equal to 0. When x equal to 1, the function equal to 0. Right? With that, we can make a table. Divide. Right? Then the test point will be between each numbers for each interval. So I just pick any number. Here I choose -1. Here I can choose 0.5. That between 0 and 1. And then here I can choose 2. Those are the test points. What I test for is I'm going to put in the function. Right, xy minus 1. So xy minus x. Now we find the values for that. Hit second trace values. Hit enter. Now when x equal to -1, hit enter. Y equal to 2. We don't even need 2. Just make a little table real quick. X equal to -1, y equal to 2. When x equal to 0.5 equal to negative 0.25, and when x equal to 2, y equal to 2. So -1 is y values is positive. When x equal to 0.5, y equal to, or f of x is negative, and when x equal to 2, y equal to positive. Right, so the sign chart, and we put the test point between the values where the function equal to 0, and then finally just go back to the problem. What we actually want, well, what we want is greater than or equal to 0, right? Meaning that we're going to pick 0 and or greater than or positive, 0 and positive. So positive is here and here. And also we pick 0, right? Because it has an equal sign. So we can choose this point as well. Then we can put just -infinity and infinity. Then we have the interval. So the answer is -infinity to 0, or from 1 to infinity. Right. So once again, we have polynomial function. Polynomial function can only polynomial function is defined everywhere. So it is continuous and defined everywhere. So there's only 3 possibilities: equal to 0, greater than 0, or less than 0. Now, once we find where it is equal to 0, the rest, if it's like this, then we're positive, negative, and positive above the x-axis, below the x-axis, above the x-axis. So positive, negative, and positive. Right? So we just find where it is equal to 0. After that, it can only be positive or negative. And also it cannot be, it is continuous. So we won't have the graph that will like this. And then do something. It cannot go like this because the graph is continuous. Right? So we cannot just have that. It is continuous and it have to go 0 here. But it cannot have 0 there because we already found all the zeros possible. So because of continuous, we can determine that. Right. So that's the point. We just need to test one point, and when we test that, it will determine the sign of the whole polynomial. in that interval, and that helps us to answer the question. Right. Here's more example. X minus 2 cubed times x plus 1 square equal to 0. Once again, in this case, we try to write this in the right form, but we don't have to because this time we already have in the right form where the function is x minus 2 cubed x plus 1 square. Right, so it is in the right form already, and we already have that. Next, we're going to solve for it. We need a function equal to 0. So I save some time and just factor it already. Sorry, equal to 0. Right, we have two factors equal to 0, so we have x minus 2 cube equal to 0, x plus 1 equal to 0. So that gives us x minus 2 equal to 0, plus 2 on both sides, x equal to 2. And x plus 1 equal to 0. So minus 1 on both sides, x equal to negative 1. Right, so x equal to 2, x equal to negative 1. And also from the previous section, I mean section 3.2. This is 3 multiplicity 3. So multiplicity equal to 3. Here we say multiplicity equal to 2. As far as this problem goes, it doesn't affect our problem, but it helps us to do to double check. Right, so first we draw a number line. Pretty much a number line for x. Put x on the top. It's actually a number line for x. Here at the bottom, we just write a function x minus 2 cubed x plus 1 square. Right? Now we have two values, x equal to 2, x equal to negative 1. It doesn't matter the scale. The negative 1 is on the left side of 2. So make sure it is in the right order. Right? And when x equal to negative 1, the function equal to 0. And when x equal to 2, the function also equal to 0. Right? With that, we can divide this into table. By the way, this step is on the exponent sign chart. Right, now we test. Just pick a number in between here. Any number will do. Would be negative 3, would be 0, 1, just do 0 here, the test point, and then 2. I'm going to choose 4 or 3, doesn't matter. Right, I recommend you just evaluate using the calculator, or it will be quicker. Oops, x minus 2 cubed x plus 1 square. right? We just evaluate the function. We don't need the graph. Of course, the graph will help us too. Right. Second, calculate. And now we're just going to put in the test point. -3. Let's put this real quick. -3. It is -500. 0, -80. And 4, +200. Right, -3 is -0, -80, which is negative, and 4 is positive. Right. Next, what we choose less than 0, right? Meaning I'm going to choose positive. Less than 0. That means we're going to choose negative, less than 0. So we have here and here. We do not choose 0, so we do not choose 0, so that's an empty circle. So we have that part. So when we have that, it is easy to write the solution. It's -3. Sorry, don't write -3, it's a test point. -infinity to -1, write the interval. And then -1 to 2, not including the -1. Now as you see, this is the graph. It is below the x-axis from -infinity to -1 and from -1 to 2. When x greater than 2, the function is above the x-axis. Right, one more thing. On the previous sign chart, we have the sign alternating. On this one, the sign do not alternating here. So the only difference here is because at -1 here, multiplicity of 2. If it is the multiplicity of 2, when we go across when we go through the 0, it will touch the x-axis and turn around. So here's -1. It is negative, touch the x-axis and then turn around, because it is multiplicity of 2. So that's why the sign will not alternate. This is multiplicity of 3 at 2, the sign will alternate. Bottom line is, if we have an even multiplicity, the sign will not change. If we have an odd multiplicity, the sign will change. So in that case, all we need to do is just do one test point. We don't have to do all of this. Right. We see that in the next example. For this one, once again, already in the right form. So we're just going to solve for it. Equal to 0. X minus 1 square, x plus 3 equal to 0. So x minus 1 square equal to 0. And x plus 3 equal to 0. So x minus 1 square equal to 0. So x minus 1 equal to 0, or x equal to 1. And this is multiplicity of 2. And here we have x equal to -3 and multiplicity of 1. Right, raw number line. Right. here we have x equal to 1 and x equal to -3. So -3 is on the left, 1 on the right. X values the function equal to x minus 1 square x plus 3. So when x equal to -3, the function equal to 0. When x equal to 1, the function also equal to 0. So that defines the number line, right? So in this case, of course, we can use the sign chart, use the test point, just pick a number in between each interval. Or we can also just don't need to do that. Now notice that if we look at the end behavior or the highest degree, the right hand side will go up, so we know it's going to be positive. If we use the end behavior and behavior near 0, the highest power terms x squared times x, so x cubed. So when x positive, it's going to be positive. When very big number, so on the rightmost interval, it's going to be positive. And then 1 is multiplicity of 2. When you be close to multiplicity of 2, it's going to be positive. And -3 multiplicity of 1. 1 is a multiplicity of 2. So when close to 1, it will touch the x-axis and turn around. So both of them are positive. At -3, an odd multiplicity, so it will go through the x-axis. So 1 is positive and 1 is negative. So we don't even need the test point. It should be negative, positive, and positive. Right. Once again, end behavior. And then when we go, when we see the even multiplicity, the sign will not change. When we see the odd multiplicity, the sign will change. But the test point is easy enough. Choose -4 here, then choose 0, and then 2, right? Right, so I have x minus 1 square and x plus 3. Right, get the values. -4 it's going to be 63. Sorry, -4. -25. 0, 3, and 2, 5. Right, so -4 is negative, 0 is positive, and 2 also positive. Right, so exactly like we done earlier. By the way, this is the test point or sign chart. Right, now what we choose is greater than or equal to 0, so we choose 0 and then we choose positive. We choose 0, because when x equal to -3, x equal to or x equal to 1, the function equal to 0. So we choose those points, choose 0, and then positive is in this interval and that interval. So we see that it go from -3 to infinity, and including the 1 and the 3. So pretty much the answer in this case will be, sorry, not parentheses, it including the -3. So the answer from -3 to infinity. -3 to infinity. Right. So that is polynomial inequality. Next we have rational inequality. It is almost the same in the definition. That is, so we have rational inequality where we have one of those forms where the f of x is rational function. Right. Next, the way we do it is almost the same as solving the polynomial function, except this time we have the top and bottom. So for polynomial function, if the top equal to 0, the function equal to 0. If the bottom equal to 0, the function is undefined. Now, we have rational function. So there's, instead of positive, negative, and 0, there's one more possibility. Right. So there are 4 possibilities now. It could be 0, it could be undefined. So we take care of those 2 scenarios first, and then we have 2 left, positive or negative, right? So 4 scenario, positive, negative, 0, undefined. We take care of the undefined and 0. We only have positive and negative left. And for positive or negative, the sign chart will take care of it. So that's the idea. Right. Let's look at the first example. Right. So we have that, which is already we already have the function. So in this case, we're going to solve for f of x equal to 0, meaning where the top equal to 0. Right. So we have x minus 2 cubed, x minus 4 equal to 0. That is the top equal to 0. And here we have x minus 2 cubed equal to 0, x minus 4 equal to 0. So if x minus 2 equal to 0, or x must be equal to 2. And this is multiplicity of 3. That power. And here x minus 4 equal to 0 plus 4 on both sides, x equal to 4, and this is multiplicity of 1. Except we don't really need the multiplicity, it's just a way to check it. So we have x equal to 2, x equal to 4, right? So that is where the top equal to 0, which make the function equal to 0. Now, where the function is undefined, that means where the bottom equal to 0. So we have x plus 1 square equal to 0. So we put x equal to -1. And so this is multiplicity of 2. And so that is the values. Make the bottom equal to 0. That means the function is undefined. Now we construct the sign chart. I said there are 4 possibilities: 0, undefined, positive, and negative. We find 0 and undefined. Now we just need to solve for positive and negative. That's where the sign chart comes into play. So test point and sign chart. Right. We have x and negative infinity, infinity, right? So you have 2 and 4 and negative 1, right? Put them in the right order. The scale doesn't really matter. Just make sure it is in the right order. Negative 2, negative 1, 2, and 4. With that, I'll write the function first. X minus 2 cubed, x plus 4. Sorry, can't pronounce space, but that is this function. Right. Now, when x equal to negative 1, the function is undefined. I will not write, just write undefined. When x equal to 2 or 4, the function equal to 0. Right, now the test point. Negative 1, less than that, choose negative 2. 0 is between negative 1 and 2. 3 between 2 and 4, and then 5. So those are the number in between. Right. If we have a calculator, I recommend you just evaluate that with a calculator. Right. X minus 2 cubed, x minus 4 over x plus 1 square. Right, let's evaluate. At negative 2, it is positive. Here we go by the even multiplicity, so the next one also positive. And then the next one. Three is negative. And then 5 is positive. Because here's an odd multiplicity, the sign will change. Right, now the answer. We want greater than or equal to 0, meaning we're going to choose 0. And then we choose positive. Right. I'm glad I go back to the previous example. I'm sorry. This one less than or equal to 0, right? So we have to choose negative. Sorry, less than or equal to 0, choose negative. So this is the previous example that I messed up. Right, choose 0. Right, and then choose negative. So the answer is not this, but from negative infinity to negative 3, including negative 3, and then the isolated point 1. Sorry, didn't pay attention there. So less than or equal to 0, and negative. Right. So this is a sign chart here, and so greater than or equal to 0, choose positive. So the answer, let's choose 0. Remember, we cannot choose undefined. So 0 is here and here. And we have to choose positive. So we can never choose -1 because it makes it undefined. And then we choose positive. Positive here, positive here, including the point, and then positive, I'm sorry, that's negative, and then here. Right, so that is the answer. So we say from -infinity to -1, not including the -1, from -1 to 2, but including the 2, and then from 4 to infinity, including the 4. Right, so the sign chart will tell us that, yeah, we have to zoom way out to see what is our change of windows, because you see that up to 32, so we have to change the y values to -100, something like that, in order to see the actual graph. Yeah, so there's something, and then let's change from -2 to 3 to 5, sorry. Right, so that's what we have. Yeah, that is better. So it's positive from -1 to 2, and then it's positive after that. Make the y values a lot bigger. Yeah, this is much better. Right, so we have positive up to -2, but not at up to -1, but not including -1, and then from -1 to 2 is positive, and after that is positive. This part is difficult to see because that value is very small. So we just look at the table. Yeah, for 3 and from 5 and on, those are the values, kind of small. Right, so that's what we have. Right, the next example, a little bit tricky because we have x plus 1 or x plus, we do not have 0 on the right hand side, so we have to solve for this first. To do this, we subtract 2 on both sides. Right. What we do next, we do not multiply x plus 3 on both sides because we don't know if it is positive or negative. If we multiply by negative, inequality reverse, and that is a problem. So we don't multiply both sides. Oh, because if it is 0, then it's undefined. What we do instead is we find the common denominator of x plus 3. So we do multiply x plus 3 and divide by x plus 3 next to it. So what I have is x plus 1 of x plus 3 minus x plus 3, and there's 2 x plus 3. Combine the top of x plus 3, I have x plus 1 minus 2 x plus 3 produce subspace and continue over here. X plus 1 minus 2x multiply them out minus 6 over x plus 3. So that gives us x minus 2x is minus x, 1 minus 6 minus 5 over x plus 3. That's less than 0. Right, so this is what we have in the right form, and this is the function. Yeah, so when we don't have the right form, we have to solve for it. Make sure 0 is one side, on one side. Right. And then the problem, we just need to write, less than 0. Right. That's good. Next, we're going to make the top equal to 0, the bottom equal to 0, and solve it. Meaning we need the function equal to 0. That's where the top is equal to 0. So plus 5 on both sides, negative x equal to 5, or x equal to negative 5, and this is a multiplicity of 1. And then we need the function is undefined. And that means the bottom equal to 0. So you have x equal to negative 3, and that is multiplicity of 1 as well. Right, the next step is the sign chart and test point. We have x equal to negative 5, make it equal to 0, and x equal to negative 3, make it equal to 0. Right, so the function minus x minus 5, x plus 3. So we have negative 5 and negative 3. Right, negative 5, we make the top equal to 0, we make the function equal to 0, and negative 3, make the bottom equal to 0, so the function is undefined. Right, now test point. Negative 6, negative 4, and then 2, 0 here. Right, evaluate the function. Negative x minus 5, x plus 3. The values. Need to change this back to the standard graph. Right, by the way, we need less than 0, so we have the answers here and here. Up to this point, and from this point on. Right, we need the values though. -6. I think it's a nice habit to write out, keep track of what we have. -6 is -1/3. -4 is +1. Positive. And the next one is going to be negative because odd multiplicity. So what do we choose? We're trying to solve for less than 0, meaning we want to choose negative. Negative here. We don't choose 0, so just ignore that and choose negative. So the answer here, -infinity to -5, union -3 to infinity, do not including -5 or including the -3. Right. Next we have this example. It is in the right form already. This is the function f of x. So just need to solve for where the function is equal to 0 or the type equal to 0. So type equal to 0, and here we have x equal to -3, multiplicity of 2. X minus 1 equal to 0. So we have x plus 3 equal to 0, or x equal to -3, or x equal to 1. X equal to -3, this is multiplicity of 2. X equal to 1, multiplicity of 1. Yeah. Multiplicity of 2, multiplicity of 1. That is where the top equal to 0. Just put that in the box. Now, the function is undefined. Meaning the bottom is equal to 0. X plus 6 equal to 0, so that's easy. And this is multiplicity of 1. And this is at the bottom, it's undefined, so I'm gonna box that. Is that, use the circle, is that, right? And then next, it is the sign chart, or test point. Or test points. X right, I just have the function here. That is the function f of x. Right, now the points -3, 1 and -6. At -6 the function is undefined. At -3 the function equal to 0, and then 1, the function equal to 0, right? So negative 3 is even multiplicity, so the sign will not change when we go from here to there. Right, this point. Negative 7 here will be good. Negative 4 here, 0 and 2. I said it is a good habit to write down everything. Right, we have x plus 3 square times x plus 1 over x plus 6. Right, get the values. Right, another way to get the values, if all of them are integers, just go to the table. Negative 7, right, that is 96. Negative 4, that is negative 3 halves. 0, it is 3 halves. Positive. And then 2, 75 over 8. Right. Negative 4 is negative 3 half. X equal to negative 3 multiplicity of 2, the sign will not change there. So there's something off here. Okay. Minus 1. Yep. Right, let's find the values is negative 7, 128. As you see, because we expect to have the same sign here when we go past negative, when we go past multiplicity of 2. So when we have something like this, we know something is not right. So that is a very good way to check. Negative 4 is negative 5 half. 0 is negative 3 half. See, both of them should be negative. And the next one should be positive. 25 over 8. Once again, even multiplicity here, so the sign will not change. The other one, odd multiplicity, so the sign will change. So that's exactly what we have. Right, now what do we choose? Greater than or equal to 0. So we're going to choose 0 and we're going to choose positive. When we choose 0, we can only choose 0, never choose undefined. So that is we choose 0, don't choose that, and then choose positive. So positive here and positive here. Notice there's an isolated point. Yeah. So the answer, negative infinity to negative 6, not including the negative 6, an isolated point -3, and then 1 to infinity, that including the 1. So bit tricky here, so that's why we have to be careful with this. So from the sign chart, yep, like I said, the multiplicity will help us to check our answer, and we have the sign chart. That just go back to the problem and choose what do we want, and we never choose anything that make the bottom equal to 0, because that's undefined, so that will never be part of the answer. And let's go back to the graph. You see positive from 1 to infinity, and from -6, you see that's very big values, so we're going to check for very big values later, but will be negative, and there's a 0 at -3, right? And if we change the values, because here -7, the value is very big, so I have to change the maximum to be very big number. In that case, we will see that is positive up to -6, and then undefined -6. After that, it will be negative and then positive. Right, so that checked. Right, next problem. So once again, this is in the right form already. I have the function. Now, the function equal to 0. That means the top is 0. So you see the multiplicity actually help a lot to check our answer. So top equal to 0, we have x minus 1 square equal to 0, x plus 5 equal to 0. So x minus 1 square equal to 0, so we have x minus 1 equal to 0, so x equal to 1. Multiplicity of 2. Because of that power of 2. Here we have x equal to -5, multiplicity of 1. And then we have where the function is undefined, meaning the bottom is 0. So x minus 3 equal to 0, so x equal to 3. And this is multiplicity of 2. Right. So we find where the function is undefined, we find where the function is equal to 0. The other possibilities left are negative and positive. X, f of x, negative infinity, infinity. Right, what do we have? X equal to 1, x equal to -5, x equal to 3. Sorry, this will be a circle. Make it undefined. Right, -5, 1 and 3, put them in the correct order. right? When x equal to 1, the function equal to 0. When x equal to negative 5, the function equal to 0. And this is undefined when x equal to 3. Right. Test point. Right. Let's just say if we don't want to use the test point, here we see the highest power of x. When we do all of this, this is x squared times x, so x cubed over x squared. So reduce to x. So when we put in the big number, so this will be positive, and then we can deduce the rest. But let's just use the test point here. Negative 6, 0, 2, 4. I said it's a very good habit to write out everything. Right. Oh. Standard window. Right on the top, x minus 1 square, and then x plus 5, x minus 3 square. Right. Let's find the values. Once again, this is just from the table because all of them are whole numbers, I mean integers. Right. And also what we expect is that only negative 5 is multiplicity of odd multiplicity, so the sign will change here. Everything else it's going to be the same, because even multiplicity, the sign will not change anywhere here. Right. Go to table. Negative 6 is negative 49 over 81. It's negative. Right. Multiplicity of 1, so the next one should be positive. Right, at 0. It is positive 5 over 9. Positive. Now, even multiplicity, the sign will not change. So you will expect to have plus and plus here. And when 2 it is 7. And when 4 is 81. Just write it positive. Right, what do we choose? Less than or equal to 0, meaning we're going to choose 0, and then we choose negative because less than 0. Right, first choose 0. You can choose 0 here, you can choose 0 here, because that's where the function equal to 0. Can never choose anything that makes the bottom equal to 0, because the function is undefined. So we choose the 0, those two. And then it's negative. So the answer here is negative infinity to negative 5, including the negative 5. And then we have an isolated point 1. Right, we write that in the set of a number 1. Right, let's look at the graph. Right, as you see, it's negative up to this point should look like negative 5 here, and then it is equal to 0 when x equal to 1. Everything else is above the x-axis, so it's positive. Right, so this section is not that difficult. For polynomial, we can only have 0, positive and negative. Once we find it is equal to 0, the sign chart will tell us where it's positive or negative. For rational function, for possibility could be 0, could be undefined. When those two out of the way, we have positive or negative. The sign chart will tell us. And finally, just go back to the problem. When it's greater than or equal to 0 and positive. Less than 0, negative. Less than or equal to 0, 0 or negative. Once again, sorry about that. And then that's all I want to cover in this section. As always, thank you for watching and see you in another video in course algebra.